And okay, now you should be able to see my slides. So the things we are going to do today, it's in two different parts. We are designing a little bit, and we will use Tinkercad. We will design a flow cell, master for making some microfluidics, and also I want to give you some tips and tricks, for example, how to make an NMR holder or something similar. In the second part, then we have a little break, and on the second part, we are going to check which kind of 3D printers we have, how to use them, what's the difference between them, and also how to make the 3D design that you did ready for 3D printing. So if you did the course last year and also the years before and the years before, you probably have already designed something. So those ones are from the students of the course. You should be able to probably recognize some of them. And the nice thing of 3D printing is actually you can print wherever you want. So if you know how to design, then you can 3D print it. This, for example, is from Max last year during his bachelor, and this is clamping together quite huge millifluidics. It's important because you can do, again, whatever you want that you cannot do if you don't have a 3D printer. So if you want to make more space in this chamber, it's difficult. You just 3D print another things, and now you have two different places where you're putting your samples. Bram, for example, designed this. So this is the standard DVDs that we have in the lab. We want to have a flow cell, and instead of buying it or checking if we can buy it, we just 3D print a holder. So Bram designed this one, and then he made the cuvette. We were looking only for colors. So here you can attach glass on the front and on the back, and you have your flow cell. So the first design that we will do today, it's an improved flow cell, because you can see this one is still pretty huge. The beam of the UV, it's only in the central part. And if I have all the rest of the volume here, it means that I'm losing a lot of time between one experiment and the other. So I want to have a better window here, and then the rest, it's just plain solid. Second design that we are going to do, it's a master for microfluidics. And again, if you follow the course last year, the standard method for making the master is to put the photoresist, usually SU8. You spin it on a silicon wafer, you expose it to UV using a mask, you cure it, and then you have your master for microfluidics. Once you have your master, you put PDMS on top, cure PDMS, remove the PDMS, and attach this PDMS slab on top of a glass slide. The design that we are going to do, it's quite long. This is why I'm going to use a 3D printer. It's also easier to change the design as I want. And it's a microfluidic for flow focusing, for flow focus. So here is one inlet. So the liquid goes in both ways and come here. This is the outlet, and this is another inlet. So if I'm using water and oil, I have oil in water flow focus, or I can do water in oil or oil in water, one of the two. So the things that we are studying, it's the discussion between the diffusion between the inner flow and the outer flow. This is why I want to have it so long. I did it already. This one is one of the 3D printed master that I did. You can see that it's pretty flat, and this is the channel, or it will be the channel. And this is 400 microns thickness and 400 microns height. Once more, this is on the microscope. Once more, the interesting part of 3D printing is that this one was kind of flexible on top of the microscope, was not really nice. So what I did was actually designing a stage for the microscope where to fit this microfluidic. So now it's way more stable and easier to use. What we are going to see today, it's only the 3D design part. It's not a rendered 3D design. So this one, it's another game, and it's not as easy. I had some problem because I have too many corners. I could have predicted it, but I didn't. So the corners are not really nice for fluidics. So what I want to do, I want to have something circular instead of the square here. So it will be 2 centimeters, 2 centimeters for the two inlet, 5 centimeters for the outlet, and the diameters of this one will be 3 centimeters. The height 400 microns and 400 microns width. Say so, we can go on Tinkercad. So if you did your own account, you should be able to enter here. And then you can just start clicking with create new design. And then you wait. If you are here, this is the build plate, and those are the objects that you can use. This is how you see the plate. So for example, if I click on top, I will see this view. If I click here, here, wherever you want. So right click and keep right clicking. This is how you move the stage. You have zoom in and zoom out, and practically that's it. No, sorry, another thing is if you click shift, if you keep pressing shift and right click or left click, right click, you can move the stage. There are two main things that you can do in this program. It's not the perfect program for 3D printing, but it's quite easy to use. So if you want to make something extremely complex, this is not the program to go. But if you want to make something simple, this is really nice. So the two things that you can do, if I just put a cube here and let me put a sphere, those are your 3D objects. Two things you can do in this program. If I put them together, I can select them both and I can click on group. This is one thing. So now this is only one single object. So they are fused together. The other things that I can do, if I pick up my cube and my sphere again, I put them together. But now this one, it's a solid, and this one I will put whole. Again, I'm selecting both of them and I click on group. Now one object has been subtracted by the other. Those are the two main things that you will use with this program. Everyone still with me?
Yes.
Okay. Good. Then we will learn on the go for making the first flow cell. If I click on the corner, I can see the sizes. So coming back, putting the cube for the flow cell, I select my, so if you click, you can just change the values. So my flow cell should be 4 centimeters by 30 centimeters. And the height, if I click on the height, it should be 1 centimeter, so 10 millimeters. This is already the shape of my flow cell. Now I want my inner part of the cell, and let's say that I want, for example, 1 centimeter by 1 centimeter. Maybe it's too much, let's say 15 and 15. And this should be my internal part of the flow cell. Now the tricky part. So if I want to put this one in the exact center, I can do it by hand, but it's better if I align them properly. So I select them both and I click on align. And now there is this other grid coming here. This grid means align it on the y-axis, and this one means align on the x-axis. So now they are perfectly centered. Then the other things I push it through, because this one I want fully whole. Select them both and group them. This is my flow cell. Now I need the inlet and the outlet. So I will make a cylinder. The diameter should be, let's say, 5 millimeter and 5 millimeter. Again, if you click on this one, you should be also able to see the rotation. So this one naturally should be 90 degrees. All right. And again, if I select them both and align them, I can align here in the Y direction, but it's useless. But I can also align it on the Z, and this is the things I want to do. So if I align them on Z, then the inlet is centered. I can just push it through. Naturally, I want my inlet being here. So with arrow keys, you can move on the Y and on the X axis. With this one, you can move it on the Z axis. Another important thing is the snap grid. So if I press the arrow key, this object is moving off 1 millimeter. And that's, as you can see here, I still have some space that I don't want. And that's because if I move it off 1 millimeter. If I want to move less than that on the snap grid, I can put 0.1, and then each single movement, it's 100 micron. So this is where I want my inlet. And I simply do the same for the outlet. So I pick up another cylinder. I make it 5 millimeters and 5 millimeters. The height is fine. I want to rotate this one of 90 degrees. I need first to make this one. And then I can align this one to the center. All right. Once it's in position, I select everything, group them, and this is your flow cell. Inlet, outlet. All right, then this one, I see that it's not perfectly on the grid, so I want just to put it back on the grid. This is the distance between the build plate and the object. Now, another thing that I know is that if I make this flow cell, and this is the inlet and this is the outlet, I will have a problem with air bubbles. So if some air bubbles will come from here, they will probably be trapped here. And this is something I really don't want. So I can make a triangle. This triangle should be 1 centimeter. I can rotate, for example, 90. And the things I'm going to look for is something like this. This one, I'm practically doing it by eye, but it's just for giving a little bit of angle for the air bubble to go out. Just something like this. So is it already 1 centimeter? So it's the same size. I can just group them. So air bubble, they should go in the outlet directly. And if you have finished this one, you have your first design. Now this is a 3D view. So 3D view means that I'm using a camera, and the camera, even if this side here is the same of this here, you still see this one bigger. So if you want to change this view, you can click on orthographic, and this is how it should like, how we like in orthographic. So now it's the sizes are better, but it's difficult to see them in 3D. So with this one, you can switch between 3D and orthographic. And other things, if you are writing your report or your paper or whatever, and you want to take a picture of your design, you can take it directly from here with a screenshot, but this is not that nice because you have the grids. So the things that you can do if you want to have your cartoons in 3D, you throw them away from the base, you focus on them, you change the camera as you wish, and then you just take a picture. This is with the white background, so you can put it practically wherever you want in your paper or thesis. When you're done, you bring it back. And now that you're far away, you can click on home for going back to the standard view. All the rest of the people, can you tell me where are you?
I'm at it.
Okay.
Not completely finished yet, but I get the idea.
Okay.
I'm currently ring up with the roof kind of thing to get rid of the air bubbles.
All right. Now, it can happen that you have a mistake here or there. And the nice thing, if you started the design here, I can select this one and ungroup every single things that I did. So if I have a mistake, I can correct everything.
So Vito, how long does he remembers the components it is built upon? So how long can you still ungroup?
Forever. So if you start designing here, forever. If you are importing a design from somewhere else, it will not remember anything. But for here, I have plenty of design from years that I can go back and ungroup them.
Yeah, but I mean, if you now ungroup this one, you get 2 cylinders, a triangle, and a square.
Yeah.
When I made the block inside the bigger block, apparently my vertical block was much higher than the other one. So now I have my device floating above the XY plane. How do I get it to the floor?
With the triangle on top, this one.
Activate gravity.
If you click on that one, you can see this one is the distance from the plate. So if you here, now I click 0, it will go on the plate. Now, for the microfluidics, we have 2 inlets, 1 outlet, and the round circle. So I'm making those one separate. And I say that I want 400 microns, but I will make them, no, the white should be 400 microns. The width, this one I will make 100 microns more, so it will be 500 microns, and I will explain you later why. No, sorry, I was stupid. This one is the length. Length should be 20 centimeters. 20.1. Those 100 microns, I will explain why I'm doing those 100 microns more later. And the height should also be 100 microns more of what I want to have at the end, so 0.5. This is one of my 2 inlets. If I Control-C, Control-V, I just make another one. So this one will be my second inlet. My outlet I can copy paste and change only this one to, I say, 5 centimeters, so it will be 5 and 10. This one also goes somewhere here. And I will make my circle. I say that I want 3 centimeters. 3 centimeters. And to those one, I need to add the width of the channel. So it will be 400 microns, and it will be 400 microns. The height for now I will leave the same because it's easier to change it later. And the things I can do, it's copy paste this one exactly, making the internal one that will be 330, 30. This one, it's my inner block, should be taller than the outer block and should be a hole. Now I can align those two on the X and on Y. As always, I did a mistake because this one should not be 400, but should be the double because it's a circle. Then I realign them on Y and X, and I group them together. And now I can change this one to 500 microns. And this is my circle. So more or less, the design should already look like this. I put them more or less already near where they should intersect. Select them all, align them, and I align them only on this axis. So now everything is aligned. And now I need to fuse them together. So I did 100 microns more because every time I use my arrow key, it's moving off 100 micron. So I know that if this one is going in there, it's 100 microns. So this is why I did 2 centimeters and 100 micron, because in the intersect point, it will be 100 micron that they are together. So the total length of this one will be 2 centimeters. I move and do the same for this one. Yeah, this one was not perfectly on the plate. Right. And this is another 100 microns.
In relation to your previous design, you had also 90-degree corners where the two fluids are intersecting, and now you don't have 90 degrees anymore there. Will that have an influence on your flow?
Hopefully. Hopefully.
It's not that you need the 90 degrees there for the perfect focusing.
No, actually, the nice thing of this one is that the following design, if this one don't work, or this one doesn't work. Hey, come on, move. Is to make the inner circle more like this, or bend on this part here, so that you have a little bit more pressure. But the nice thing of this one is that I can do a lot of different design in a very fast time compared to soft lithography.
Absolutely.
So this is just one other iteration.
And will the surface be flat enough to do the sealing on the glass?
Yeah. All right. So hypothetically, you should have reached this design as well. The things I need for this design is to put it somewhere where I can pour the PDMS. So I want to make kind of bigger chamber. Something like this should work. I want to make this part inside. I'm just doing it by eye because this is not really important for the final design. The only thing important is that I have a border for containing the PDMS. And this one should not be exactly at 0, but should be around, let's say, 5 millimeters at least. Should be empty. If I couple those two, then I have my PDMS chamber. And then I want to put this one fused inside this chamber. So I just put it a little bit on top. I move it. If I select them both, I can center them here and here, so the design is centered. And then I can lower, not this one, but I can lower this one until it's touching. And also in this case, if you remember, I did 500 microns instead of 400. And that's because 100 micron is going to fuse inside the chamber. Then I select everything, fuse them together, and this is your design. So you can pour PDMS, you can cure it, remove it, and then attach the PDMS on top of the glass. Should honestly be a little bit longer on this side because I want to puncture my exit here. But for now, it's good enough. Good enough. All right, who finished?
Yeah, I did.
Oh, Max, all right. Sander?
Almost.
Okay. Yes. I mean, just as those one are just the basic shapes, you have also shape generator in which you will be able to change a lot of parameters depending on the object. So for example, if I put the pipes, I can change the diameters, wall thickness, the angle of the pipe, and this is automatically generated. But you need first to learn how to couple all the objects together or remove part of the object, and then start using the generator. So when you have your designs, you can export them. I will do this one. It's a mistake, so I will do it. I will export it as STL. Or I can click on one of them and export and the selected shape. So now it's exporting only this one. So it's exporting this one. Now I click on this one, export as STL, and it's exporting only this part here. So the first one is a mistake because I'm exporting both together at the same time. So it's only one STL. So when I go into the 3D printing program, I cannot detach them anymore. So if I want to print only this one, I must print also this because they are in the same STL file. Now, the last thing before going for a coffee break, I want to show you something a little bit more complex, but it's a small trick. Let's say that you want to have an NMR stand. So I need a lot of holes in this part here. Let's say that we're doing, I don't know, 3 centimeters stand. My NMR tubes are, how big they are? 5. Let's say that we do 6 millimeter by 6 millimeter holes. Naturally, this one should be a lot taller and should not be on the bottom, but I want to give here, let's say, 1 centimeter of plastic before the tube. Now, for doing this trick, when you move those things around, they don't have an origin point. So I need to set up an origin point, and I do it with the ruler. So I, for example, pick up the ruler, put it here, and now if I move this object, I move it compared to the origin point. That's the important thing that I want to show you. So if I'm clicking here, what I want to do is having all of those holes for the NMR tubes in this block. And how I'm going to do it, it's using this button here, that it's duplicate and repeat. So I click it, it makes a copy of it, and now I can move it, for example, of, let's say 2 centimeters. Now I have this position, and if I keep clicking here, it will make exactly the same replica at exactly the same distance. This one probably it's too much.
How you did it again?
This is the trick. So you need to have an origin point. So you click on the ruler and put a ruler somewhere. It doesn't really matter for this trick. I click on this one. Instead of copying, paste, and moving it by hand, so instead of Control-C, Control-V, I click on this button here, that it's duplicate and repeat. So this is my first copy, and I say that my copy, this is, if you see the green line, is the distance between the origin point and my object. So instead of being 16 millimeter, I say that I want it 2 centimeters on the right. So instead of 16, my next object should be at 36. Once I have made this first movement, if I keep clicking here, it will just duplicate and repeat my last. All right. Then you just group them. And here you have your NMR stand. Maybe you want to personalize it. Yeah. And now you have your personalized stand. But the trick was only to show you how to use the ruler and the duplicate and repeat. Maybe I will save this one. If you don't want the ruler anymore, you can just remove it. Now, in the last 4 minutes, last but not the least, is another tips. If you are planning to do something that probably is already online, so let's say that I want to have a stand for the Arduino for the back of my FUMUD. One way is to bring up every measure of the Arduino and then redesign the stands by hand. The other thing is check if you have already something online. So for example, if I import and I already download the Arduino, so hypothetically, if you download this one as a STL file, you can import it and you can check where the holes are or the dimension and everything that you need for making a stand for the Arduino. So now Tinkercad thinks that this file is too big, so it's not going to import it, but usually it works. The other thing is when you use files from the internet, it's always important to see if you can use them. So you should check the license. This one, it's CC BY, so you just need to say who is the main author. So if you click somewhere on the Creative Commons, it can also say what you can and what you cannot do. So you are free to share, adapt. So you can also make different things on this design, but you cannot commercialize it. And you should always say who was the initial designer of this. This is important when you are using 3D files that you take from the online. Ah, he did. So this.
When it comes to electronics like Arduino and Raspberry Pi and stuff, Tinkercad also has built-in models of them.
Yeah.
Under circuits components. So you could also use them.
Yeah, but this is a little bit general. If you want to have a vials, if you want to have an Eppendorf and you don't want to design by yourself, most probably you can find it online and check the dimensions. So if I want to make a board for this one, I already know where the holes are that I need to put it on my board. I know where are the connectors, so I can make holes for the connectors. I know where are the pins and so on and so on. So it's easier. It's actually way faster if I just use a design that it's already here.
Yeah, fair enough. It's a good idea anyway.
All right, more question about this part here.